Now let's go to single phase full wave rectifier and see what will be the controlled bridge or the controlled single phase full wave rectifier, and we will consider the generic case, which is RLE, because this is more general. So I will just bring the circuit from here. So now we will start a single phase full wave fully controlled rectifier supply and RLE load. And RLE load is a generic case, which is a similar case for having a DC motor. So for the full bridge, okay, for the full wave and fully controlled, it's fully controlled. So fully controlled means all the switches are controlled, and we are supplying an RLE load. So we have 4 thyristors, similar to the diode bridge we studied before. And don't forget the naming of the thyristors, 1 and 2, and here 3 and 4. And they are connected in the shape of a bridge, and they are connected across load, and the load here is RLE. And now we need to do the sketch for VN, Vout, etc. Now let's define our variables, okay? So here we have I source, here we have I out, and we can say this is I thyristor 3, I thyristor 1, I thyristor 4, I thyristor 2. Here we have V thyristor 1, V thyristor 4, V thyristor 3, V thyristor 2, and here we have V out and I out. So these are all the variables that we can sketch. So we can sketch V source, I source, we can sketch I thyristor 1, V thyristor 1, I thyristor 2, V thyristor 2, and so on, V out and I out. Now we need to see the different states of the circuit. So the first situation, if thyristor 1 and thyristor 2 are on, and when this happens, if the source is positive and negative, so positive here will make this thyristor forward, and negative here will make this thyristor forward. Now if you fire these two thyristors, they will conduct, and in this case this thyristor is open circuit and this thyristor is open circuit. So this is the first case. So the first case, when thyristor 1 and thyristor 2 are on, thyristor 3 and thyristor 4 are turned off. Now in this case, V out, okay, will be the same voltage as Vn. So in this case, V out equal to Vn. I out will be the current coming from the source to thyristor 1, going through the load and going back to the source. So I out equal to I source equal to I thyristor 1 equal to I thyristor 2. I thyristor 3 equal to I thyristor 4 equals 0, because these two thyristors are open circuit. This voltage is V thyristor 3, so if we do KVL here, V thyristor 3 plus V out will be 0. So V thyristor 3 equal to minus V input, and V thyristor 4 equal to minus V input. Thyristor 1 and 2 are on, so V thyristor 1 equal V thyristor 2 equal 0. So these are on, and these thyristors are turned off. So when they are off, their current is 0, and their voltage has a value, or the voltage has a value. So this is the situation when thyristor 1 and thyristor 2 are conducting. Now when the supply reverse polarity, so here is negative, here is positive during the negative half cycle. So negative will make this thyristor forward. So if you give it a signal, a firing, it will be on. The positive here will make this thyristor forward. So if you give it a signal, it will be on. And here these two will be open circuit. So here thyristor 1 and thyristor 2 are turned off. Thyristor 1, thyristor 3 and thyristor 4 are turned on. Now as you can see, V out is Vn but reversed. So your positive is connected to the negative of the arrow of V out. So we can see that V out equal to negative Vn. And I out, don't forget that I out is constant because of the inductance. So I out will be going through the thyristor, and it is going in negative direction in the output, in the input. So I source equal to negative I out equal to I thyristor 4 equal to I thyristor 3. So I out will be flowing here, going through thyristor 4, going through the output in reverse direction, or the input in reverse direction, then it goes through I thyristor 3. Thyristor 3 and thyristor 4 are on, so V thyristor 3 equal V thyristor 4 equal 0 because they are on. Thyristor 2 and 1 are off, so I thyristor 1 equal I thyristor 2 equal 0 because they are off. So any switch turned on, its voltage will be 0. Any thyristor turned off, its current will be 0. To get V thyristor 1 and V thyristor 2, we will go back to the circuit. So here we have V thyristor 2. So V, if we do KVL here, V output plus V thyristor 2 is 0. So V thyristor 2 is negative V output, and V output is negative V input. So this one equal to positive V input. So if you do KVL here, you have V out plus V thyristor 2 equal 0. So V thyristor 2 equal negative V out. V out equal negative Vn. So V thyristor 2 will be positive Vn. Now we have all the equations for each situation. The question is when we will apply these rules. So let's sketch the waveforms. So let's start by Vn. Here I will try to expand the waveform a little bit so you can see it. So I will use 4 squares as pi over 2. And just I will put lines at pi over 2. At pi. So I will put vertical lines at these angles. and we will sketch for alpha equal 45 degree as an example, okay? So here we have our pi over 2. So this is alpha equal to 45 degrees. So we will have firing here, and this firing will go to 1 and 2. So don't forget that we have 1, 2 switches operating in the positive cycle. Then you have 1, 2 switches operating at the negative cycle. So what you will do, you will send firing to 1 and 2, and then you will send firing to 3 and 4. So this is in the positive cycle, and this one is in the negative cycle. Or you will send 2 firing shifted by 180 degree. So here I will wait 45 degree and I will send another firing, and this is how we write it, 3 and 4, and then we send 1 and 2 again. So we will send the firing to 1 and 2, and then after 180 degree we will send the firing to 3 and 4, and so on. And our input is a sine wave. So here is peak, here is 0, here is peak negative, here is 0, and so on. So this is the input waveform, V input. The voltage here is V max, and the voltage here is negative V max. So here we are firing 1 and 2. So 1 and 2 will be conducting, thyristor 1 and thyristor 2 will be conducting until we fire 3 and 4. When we fire 3 and 4, 3 and 4 will take over, and they will be conducting until we fire again 1 and 2. Here is thyristor 3 and 4. And here we will start again thyristor 1 and 2 until we fire again 3 and 4. So before 1 and 2, we had thyristor 3 and thyristor 4. But just, I should have moved, okay, this here when we give firing. So when we give firing to 1 and 2, they will conduct until we give firing to 3 and 4, they will conduct, and here 1 and 2 again. So before 1 and 2, we had 3 and 4. Now we know when each equation will be applied. So 1 and 2 will be applied from alpha to pi plus alpha. And 3 and 4 will be applied from pi and plus alpha to 2 pi plus alpha. So these rules are from alpha to pi plus alpha, and these rules are from pi plus alpha to 2 pi plus alpha. These are the angles. So here we are applying from alpha angle up to, this is pi, so pi plus alpha, and here this is 2 pi, so this is 2 pi plus alpha. So we know when these rules will be applied, so we can sketch whatever we want. So let's sketch first V out. So from alpha up to pi plus alpha, 1 and 2 are conducting. So from this point to this point, according to the equation here, V out equal to Vn. So here we will sketch V out as Vn. So Vn here is peak, Vn here is 0, and Vn is peak here again. Okay, but I'm taking only this part of the wave. Now, when 3 and 4 conduct, when 3 and 4 are conducting, the output voltage will be negative Vn. Okay, so we need to sketch a negative Vn. So here it's negative Vn, here it's a positive Vn. So what is the meaning of negative Vn? I will take Vn, which is this wave, but I will reverse it. So here peak negative, I will sketch here peak positive, and here 0. Okay, so this wave is negative Vn, and this wave is positive Vn. But I will take negative Vn from this point here up to the next alpha, which means before this we had negative Vn. So this will be the waveform for V out. So as you can see, V out here negative, V out here positive, V out here negative, V out here positive, then V out here negative. Someone will say, is this output voltage, is it AC or DC? So this output voltage is DC because the average is not equal to 0. Why the average is not equal to 0? Because the negative is less than the positive. Okay. Now if we need to sketch I out, because here we have RLE, so I out will be constant at its average value. So this is I out average. To sketch I source, so here are the times. So from here up to here, we have thyristor 1 and 2. From here up to here, we have thyristor 3 and 4. So here is thyristor 1 and thyristor 2. Here is thyristor 3 and thyristor 4, thyristor 3 and 4. So when thyristor 1 and 2 are on, I source equal to I out. When thyristor 1 and thyristor 3 and 4 are on, I source equal negative I out. So we can write down this rule. So here it's I out, negative I out, negative I out. So when we sketch I source, it will be this waveform. So here it's negative, here it's a positive, here negative, here positive, and so on. So it's an AC, but it is a square wave. We can also sketch, say, I thyristor 1. We can sketch any thyristor, but let's sketch I thyristor 1. So when thyristor 1 is on, I thyristor 1 equal to I thyristor 1 equal to I out. And when thyristor 1 off, it is 0. So here it is 0, and here it is I out. Then it will go to 0, and then it is positive I out again. Okay, then we can sketch any V thyristor. Let's sketch V thyristor 1. You can sketch any voltage for any thyristor. So here is omega t. Here is omega t, omega t, omega t, omega t. So we can sketch V thyristor 1. So thyristor 1 is on from this point up to this point here. So here we have thyristor 1 and 2 on. So when thyristor 1 is on, its voltage is 0. And then it will be on again starting from here. So its voltage is 0. So V thyristor 1 equals 0. V thyristor 1 equals 0. Now when 3 and 4 are conducting, thyristor 3 and thyristor 4, thyristor 3 and thyristor 4, V thyristor 1 will equal to, if we go here, V thyristor 1 equal to V input. So it is equal to V input, V input, V input. So V input is a sine wave. So what I will do, I will sketch the sine wave. So here The sine wave is peak at this point, and 0 here, peak at this point, 0 here. So I'm just sketching the original V input we have before. So I'm sketching V input we have up here. Now V thyristor equal to V input during only this time here and only this time here. Okay, so we are cutting this part of the wave and this part of the wave. Now we can sketch our V out, so our V thyristor. So it is V input, it is V input here, then it goes to 0 up to this point, then it goes again to V input, and again it goes to 0. And this is the sine wave we have. And this will be our V thyristor. As you can see, there is very important notes here. So here, thyristor is forward, okay, before it turns on. And here thyristor is reverse when it turns off. And then again, thyristor is forward before it turns on. And forward means V thyristor is positive, and reverse means V thyristor is negative. So when the thyristor turns off, its voltage is negative, and before turning on, its voltage is positive, okay? And this is the operation idea, that to turn on the thyristor has to be positive, and you have to give it a firing signal. Now we are done with the waveforms, and I will leave this here. These are the waveforms from the textbook. Okay, so we did this sketch already, but I prefer to do it by hand so you understand how we got each part of the wave. Now let's do the calculation for V average. So if we take this waveform here, so here is alpha, here is pi plus alpha, and this waveform will be repeated again. So this waveform here is repeated again here, as you can see. So this is the repeated pattern. So to get the average, so our repeated pattern is something like this. Here is pi plus alpha, sorry. Here is alpha, here is pi plus alpha, and the max is V max, and this is V out omega t, and this will be the repeated wave. So V average will be 1 divided by pi, because this is repeated 2 times, so we can say it as 1 divided by 2 pi, and we have 2 waves, or we can simply say it is 1 over pi multiplied by the integration from alpha to pi plus alpha V max sine theta d theta. So this will equal to V max divided by pi, and the integration of sine theta is cos theta from pi plus alpha to alpha. This will give us cos alpha minus cos pi plus alpha. So this integration is 2 cos alpha. So this will give us 2 V max over pi cos alpha. So V out average equals to 2 V max divided by pi cos alpha. And as you can see, that the average is function of alpha. And this is very important. So the output is controlled. not only the output is controlled, but note, if alpha equal to 90, V out average will equal to 0. Why? Because at 90, if you start to shift this point here until you reach the midpoint, you will see that the negative part will exactly be the same as the positive part if you move the alpha to 90 degree. And you can try this as a homework. You can sketch again at alpha equal 90 degree. And with the negative equal to the positive, your average will be 0. And also if alpha between 0 and 90, your V out average is positive. With alpha between 90 and 180, V out average is negative. So this circuit can give you a positive average voltage or a negative average voltage, which is very, very useful if you have a motor and you need to reverse the direction of rotation or the direction of motion. You will need to do this. You will need a negative average voltage. Okay, so this is very important. But for the current in the load, if we go here to the circuit, just I will okay, let's bring the circuit here. So here's the voltage across the load. This V out can be something like this, which has a positive higher than the negative, or it can be something like this, with negative part more than the positive. So this is for alpha between 0 and 90, and here is for alpha between 90 and 180. So here V average will be positive, and here V average will be negative. But for the current into the load, here this current here, which is coming from this thyristor and this thyristor, there is no way for this current to go back. Okay, if the current tries to go back, there is no direction here, and there is no direction here. They are all closed, which means that I out is only positive. And the sketch for this converter or this rectifier, they sketch its VI characteristic. So for this bridge, we can get V as positive or negative, but we can get only a positive current. So this is what we can get. So we can get positive voltage and positive current, or negative voltage and positive current. So this is for alpha between 0 and 90, and this is for alpha between 90 and 180, and we call this rectifier two-quadrant rectifier, because it gives you two quadrants from the four quadrants. It gives you positive V, positive I, and negative V, positive I. Why I is only positive? Based on the direction of the switches, we can only circulate a positive current in the load. Now to get I out average, it is V out average minus E divided by R, as we mentioned last lecture. So V out average is 2 V max divided by pi cos alpha minus E divided by R. And I out average is I out RMS, because the output voltage is constant. To get V out RMS, it's a V max over root 2, because it's the full wave. It is the full sine wave. So it's RMS is the same as the RMS of the sine wave. So these are the equations we need for full bridge. Okay, so please sketch as a homework for yourself. Sketch at alpha equal 90 degree. Sketch at alpha equal 120 degree. Already we did the sketch at alpha equal to 45 degree. Okay, so repeat the sketch at alpha equal 90 and at alpha equal to 120 degree. One important point, note, what will it change if we added a freewheeling diode here? So what will it change? This is another homework. So what will it change in waveforms for V out, I out, and I thyristor 1? And what will it change for V average? So what will be the expression for V average if we added a freewheeling diode for this circuit? Okay, so this is called a full wave rectifier. Fully controlled full wave rectifier, plus we added a freewheeling diode. Already we studied here the full wave rectifier without a freewheeling diode, and you know that the effect of the freewheeling diode will be removing these negatives. So please try to see what will be the effect on the circuit when we add a freewheeling diode. Okay.